Hello friends, today I am introducing a very important topic in probability of statistics, that is introduction to the concept of quantile of a probability distribution. I am sure you must have heard percentiles by now. Many of the scores of exams are reported as percentiles, not as percentages. So we are going to formally look at what is the meaning of a quantile of a probability distribution. Any probability distribution has a distribution function using which you compute the probabilities, and so the quantile function is defined something like this. So it is the smallest value such that f of y is greater than equal to p. Now why is it defined in this such peculiar way? P is a proper fraction between, remember that fy is a distribution function, that means it's a probability, so it can never be more than 1 or less than 0. So this is a function f that is ranges between 0 to 1. So its values will be proper fractions only. So you suppose give me a proper fraction p. Now I compare the values of fy. I try to find out at which point this has been exceeded for the first time. The equality may or may not be attained, that you will see in some examples. Now why I am saying the infimum? How do I know that the function is increasing from left to right? So f is a distribution function. We can prove that a distribution function is a non-decreasing function. It's a one-line proof. I will probably tell you in any time. You can also figure that out. It's not difficult. F of y means what? Probability x less than y. Now you have to think about 2 points, y1 and y2, where y1 is less than y2. Then you think probability, think about the events that x is less than equal to y1 and x is less than equal to y2. Which one will be bigger? So which one will be contained in what, and then you have the answer by monotonic property of probability. Now fy is a non-decreasing function, that is increasing from left to right. Fy cannot go below 0 and it cannot go above 1. So if you are giving me any proper fraction between 0 to 1, so then I will naturally check from left to right where fy has gone above p. So therefore I am wherever it has crossed p for the first time or attained the value of p for the first time, that is my pth quantile. So pth quantile is a real number. So for every fraction p, I will get a real number by this algorithm. Now what is the interpretation on of this number qp that you have gotten? Qp is the so if I compute probability x greater than qp, so you know that what is the meaning of probability x greater than any number a in terms of distribution function, that is 1 minus fa. So this will be 1 minus fqp. Now what will be fqp? Remember, by definition qp is a number where f has exceeded the value p for the first time, either equal or greater. So 1 minus of that will be naturally less than, here I have made a mistake, it will be okay, wait, yeah, where it is gone above p, and so this will be f of qp. So I have made a mistake here, this will be 1 minus p, sorry, okay, this will be 1 minus p. So if p is a number very close to 1, think of p is equal to 0.95. Then what is the probability of x exceeding that number q 0.95? That will be less than 1 minus 0.95, that is 0.05. So there will be a very small probability of exceeding q 0.95. So that is the whole idea. Similarly, if x is a very small number, say x is 0.25, then there is a very small, then the probability of exceeding that value will be less than 1 minus 0.25, that is 0.75, which is of course not small. But the larger value, when p is close to 1, then these values of qp can be very large numbers. Why? Because you have to because probability of exceeding that is very small. So that means it will be in the extreme right tail. So they represent extreme values. So that is the main reason why this is so important. So now look at a distribution where x takes two values 0 and 1 for 0.4 and 0.6. So I would like you to find q4 0.4 and q.5. So you check with the values. So you see how the distribution function look like. So the below 0 there is no probability. So first time it jumps up at 0, that is 0.4. But you are looking for a number where it is attaining 0.4 or above for the first time. So it is attaining the value 0.4 probability for the first time at 0. So q.5 would be 0. Now in the same way, can you argue what is q.5? I am leaving that for you. Suppose x follows normal distribution, then what is q.5? So here I will give you a hint. Remember the normal distribution. So it is a symmetric distribution because the distribution of f of minus x is same as that of x distribution of x. So what is the probability below 0 and above 0? That you think. Exponential distribution. So here you know the exact formula of the probability distribution. Here you know fy is equal to 1 minus e to the power minus y. So that you can use to solve this QP. Similarly, student T distribution. This here also the hint is that it is another symmetric distribution just like normal distribution. So distribution of x and minus x are same. So that would mean what is the probability above and below 0, that you figure out. And then compare with, you find out what is the probability of exceeding 0 for normal and student T distribution. That should give you the idea. Now here is a lemma. It is a small but important lemma that if x is a continuous random variable, that is if the distribution function is continuous, then for any p 0 to 1 you don't have to bother about this definition in this peculiar way, and then you can simply say qp is a solution of the equation fy equal to p. Now why is that so? Why in general we cannot define it like this? Because if I in this example you see, if I ask you to find also q.6 or let us say q.45, so you will not be able to find any probability that match. Here there are only two values 0.4 and 0.6, so the distribution function will be like 0, then it jumps up to 0.4, and then up to 1 it will be one constant line, that is 0.4, and at 1 it will jump up to 0.4 plus 0.6, that is 1, and remain there forever. So there in the range of the distribution function for this distribution has only three values 0, 0.4 and 1. So if you are searching the values 0, 0.4 and 1, none of them are equal to q.45 or none of them are equal to 0.5. So this equality will never be attained. So for such distributions, which we call atomic distributions, there may not be, for certain values of p, there may not be any solution of this equation. So that's why in this case we look for points where if the equality cannot be attained, at least the jump above p has happened for the first time. So, but in continuous random variable, here you can always say for any p between 0 to 1, qp is the solution of fy equal to y. Because you see, when you say it is continuous, that means f is continuous. And as we just argued in the beginning, that f is a distribution function, means it's non-decreasing from left to right, and its range is between 0 1. Now if you have to think about this result, of which you must have seen in real analysis course, called intermediate value theorem. So if I have a continuous non-decreasing function whose values are that is the range is between 0 to 1, then if you know that such a function will attain each and every value between 0 and 1. So you give me a p, I will find a y such that fy is equal to p. That is basically the intermediate value theorem. The intermediate value theorem is a bit general. It does not require monotonicity. It says that if f is a continuous function, then f will attain any value between f0 and f1. Any value between so if f is defined on some interval ab, then it will attain every value between fa and fb. Now here we know that the function is non-decreasing, so the smallest value of f is f0. Sorry, the smallest value of f is 0 and the largest possible value of f is 1. So by the same result, if you give me any number between 0 and 1, so in order for the continuous function to go from the level 0 to level 1, it cannot jump. It has to touch p somewhere. Why it cannot jump? Because continuity means you can sketch the graph without raising the pen from the paper. So at some point you will have to cross p in order to go from level 0 to level 1. So that's why the logic. So using this logic, so finding QP for exponential distribution will be very easy, no? Because for exponential distribution, you know the exact formula of Fy. So you just solve this equation. So that will be 1 minus e to the power minus y equal to p. But in this case, normal and student still also these are continuous. But the problem there is that you don't know the exact formula of f. So there you use the fact that these are symmetric distributions. Anyway. Now remark, so here I would need a correction for p close to 1. Sorry on that count. I am uploading the corrected note only after making the presentation. For p close to 1, qp represents an extreme value or a very large value, you can say, such that probability that x less than equal to p is less than equal to 1 minus qp. Remember this result here. So for p close to 1, qp will be a value that is, so you can see now why, because if p is suppose 0.99, so you will have to search for that value where f is about 0.99, but f cannot go above 1, so you will have to go to the extreme right to find such a value of y. So therefore qp has to be a very large number for p close to 1, and for p close to 0, qp will be a small number. So now these numbers have special significance. So here are some examples that I have created. Suppose x denotes the height of an adult male in a certain population. So x is a random variable because it will vary from person to person, and we cannot say with certainty that that a certain individual selected at random will have a certain height. Then q.95 will represent that value, that number, such that only 5% of the males will have height exceeding q.95. That means it will represent a large height. That means suppose say 6 feet. So that or 6.2 feet. So you will have only a small fraction of people, males who would have height more than 6.2 feet. So it's like that. Or another example I am giving, suppose x denotes the score of a student in a certain class in a particular exam. So x is again a random variable because the score will vary from person to person in a random way. So now q.5 again represents the 95th percentile score. Why? In the sense that q.5 will represent a score so that not more than 5% of the students are expected to score above 0.95. So it will represent a high score. So you see, this is the interpretation of a percentile score. So if your score is 95 percentile, that does not mean you have gotten 95 out of 100. You may very well score 85 out of 100 and still get a 95 percentile. Why? Because in that group only not more than 5% may have scored above 85. So in that case, even by getting 85, you will get 95 percentile score. Now why quantiles are important? One, I told you that they represent extreme values which are useful in many contexts. And the second usefulness of the quantiles come in the context of heavy tail distribution, something that I have already defined. Heavy tail distributions means either that only some of the moments exist, all the moments don't exist. So